So I would like to introduce the fourth speaker with pleasure. His name is Pepesza, and he's the software developer at OmiseGO, and he will talk to us about sort of Plasma and securing exchanges on Plasma. Thank you.
Hi everyone. I would like to give you an update of what is going on with OmiseGO network, this project, and where we are at the moment. So we've just launched the alpha version, basically on a testnet. It's one update away from feature completeness, and we are thinking of how does one build an exchange on top of more VP Plasma. Yeah, and this is me. Yeah, so like, what do we have at the moment in the market in general? Centralized exchanges. This is how it looks. You can find articles list of all the hacks which happened during last 6 years. And the amount of money stolen is actually impressive. And the main problem is obvious. It's custody. But if we will try to get away from custody, what then happens? We have a free option, we have non-firm orders. The whole trading experience is pretty far away from what you will get on a typical centralized exchange. Decentralized exchanges, they have quite a lot of strong points. Resilience, censorship resistance, it's beautiful. But the problem is you have full transparency, it's really hard to prevent information leakage, and it hits both traders and the market makers. So traders are being front-run. There are different techniques to fight this problem, and they all are very, like submarine sense. I don't believe anyone uses it. There are a few projects which speak about group key generation. It's a complicated protocol. By the way, we might ourselves be using it in the future. And of course, there are batch actions which are implemented all over the place. The other problem is, of course, no financial privacy, but it's more of a problem of underlying layer, the blockchain ledger itself. Yeah. And for the market makers, the problem is, cancels, like for on-chain DEXs, cancels are not free. All available funds are public, but you reveal your market strategies immediately, and it affects directly your bottom line. So it's not a very good experience. So we are looking into the way of bridging the gap between those two models. All of this is a pretty fresh research, so details will change. Yeah, and this is what we want to do. We are basically working on design which will combine off-chain order book, where you don't have this problem of order privacy, batching for trades because of performance reasons. The whole thing will work on Plasma, so all Plasma designs, they share a common problem. You never can spend, okay, there is one small exception, but usually you cannot spend money which you don't yet have seen confirmed on Ethereum. And it means if you are doing partial fills on your trades, the problem is you will have a change address, basically change UTXO, and you cannot enter this change UTXO and corresponding partial order to the next batch without compromising the security of the protocol. And this is why we are looking at batching for this one. We will scale through the batch size, not through the frequency of trades. To make the whole thing secure, we'll have validity proofs for trades, and to remove the free option. Basically, you just sign away your free option right using game theoretical design. Yeah. So how it looks: you sign a message, I intend to trade at UTXO. You give it to the venue. Venue gives this message to the operator. This is basically, this design will work on POA stage. For the POS stage, we will need to rely basically on ZK snarks to solve this one. If user spends directly, operator will reject this TX. This is how we are removing the free option at the moment. And next, order submission. Trader privately gives order to the venue. This means that the trader can actually update order as often as it wants. It can cancel the order freely, and order is not leaked on chain. And then, if there is if batch is closed, venue does batch matching. The exact algorithm is basically all we want from the trader, from the venue, is to implement this algorithm also as a instability code, or if we are not using snarks, and if we will use snarks for this for the trade, the exact details of the trading algo, they just have to be known, and that's it. Yeah. Next, venue emits a TX with validity proof attached. This validity proof is checked by the operator before inclusion. Yeah. And at the end, the outputs of this trade are unlocked by default. So in a way, this whole design works as your funds don't stay on exchange in any meaningful way. So your custody stays with you. Yeah, order canceling done privately. It's free. Venue provides signed cancellation proof. Why this cancellation proof is important? You will see basically if you have canceled the trade and venue still used the trade, you can prove that venue is cheating. And if venue just does not sign your proof, you can cancel the order on chain. Basically, the idea is to have the process where every time when a venue doesn't want to cooperate, you just escalate on chain. And this is how we want to solve the problems of censorship of every form. Yeah, Plasma will give us enough TX capacity to hopefully handle that. Yeah, unlocking the funds. So if I lock the funds before for the trade, now if I want to back out, or I do not trust the exchange anymore for some reason, I can just I just do unlock TX and emit it on the chain. Then there is timeout during which the venue will have a chance to actually publish the trade it's been compiling and proving. And if venue doesn't publish the trade with my UTXO, I just spend it. So this is how we hide the fact that basically money are moving to the exchange in moving. It's not, they are not actually moving. We're just signing away the free option right. Yeah, and of course Plasma MoreVP has this in-flight protocol. Basically, if at any moment in time data availability problem arises, all traders, all participants, they have to check if there is basically operator doesn't publish the block, so you see you gave operator an hour, and after that you have to exit. This is the basically the case where exchange would like to close the last trade. So exchange will publish the in-flight exit from the trade settlement. It will provide, in a design without snarks, it will provide Merkle proof for inputs and Merkle root of signed order set. And then we have a more VP game, exit game, which basically, thanks to predicate construction, recently published by a Plasma group, the whole predicate construction works on more VP Plasma as well. So we want to use it for the exchange trades. We have this challenge response game. A challenge makes the trade invalid. So while a trade is challenged, you can only exit from the inputs of the trade. But then you can restore the validity of the trade by revealing data which will prove that trader has actually signed that order. This way, exchange cannot exit with fake proof, basically giving itself the money, and exchange can exit with correct proof if there is a problem and operator has gone rogue. Yeah, so censorship resistance, we can achieve it using force on chain calls. Basically, if one of the players reject your message, you just push the TX on chain. Resting funds are safe, and funds locked into trades are at risk only if both operator and venue are malicious. We might be able to improve this property using snarks. Yeah. So the whole thing is very fresh. Yeah. This okay, it hasn't rendered properly. Yeah, this is a DEX flow overview for the messages. Yeah, and the end result, since we will have partial fills, we can build any type of orders on top of it. With the snarks, we can achieve privacy for the orders. We can have resting orders. Thanks to the Plasma, we have a nice throughput, like 1K transactions per second, 2K transactions per second. It basically, the bottleneck is the trader's laptop. And yeah, it's secure and upgradable thanks to predicates. Thank you.
Thank you so much, Pepesza. I just wanted to ask you, that was really interesting. Could I just ask you, what are the next things that you're working on then, given that you've already done so much?
Oh, so this design is a very fresh thing. So while we are pretty certain of its security features, there is quite a lot of work that needs to be done on basically snarks, because without snarks we will not have the privacy for the orders, and the whole thing will not be interesting for market makers.
Okay, great.
Yeah.
Thank you so much. So